Karatsuba algorithm, which follows divide and conquer strategy. So this algorithm is basically meant for multiplying two numbers. So given two numbers x and y, calculate their multiplication using Karatsuba algorithm. So this algorithm totally follows divide and conquer strategy. So we have seen earlier divide and conquer strategy for solving transcend matrix multiplication, but that was matrix multiplication. This is multiplying two numbers. So basically what happens is that in our childhood or in the school level mathematics, we used to multiply two numbers normally, right? So you can see that algorithm that we used to apply in our elementary school level was called a naive method. So in this naive method, what happens here, we multiply each digit of the second number with every digit of the first number and then add all multiplication results. That means we used to do like this. You have seen that this is how we multiply, right? Two numbers. Here, although two numbers length is not same, this number is 1, 2, 3, 4, 5, 6, 7, 8. Length is 8 and second number length is 4. So this is how we multiply and we add it all and we get the number. So this algorithm is actually, if you see, runs in theta n square. Theta n square it runs. Okay, so the Karatsuba algorithm that followed divide and conquer strategy will be having little bit lesser time than this n square. Okay, so how that happens, let us see in the next slide. So here Karatsuba algorithm, let's say we have two numbers, one is x, which is 1 4 6 1 2 3 first number, and second number is 3 5 2 1 2 0 second number. So this 1 4 6 1 2 3 and 3 5 2 1 2 0, these are the two numbers that we are going to multiply. Basically we are going to multiply x into y. So this is our x and this is our y. So what will happen, we'll use divide and conquer strategy here. So first we have to divide the first number into two parts, and second number also has to be divided into two parts. So first number is 146, which is, you can say that it has been, first part has been divided into A, second part has been divided into B. So 146123 can be written like this: 146000 plus 123. So this is 146 into 10 to the power 3 plus 123. So in a generic form we can write x equal to a star 10 to the power n by 2 plus b. So here n is the length of the number. So in this case both the numbers length is 6. So 6 by 2 3, that means a into 10 to the power 3, that means 146 into 10 to the power 3 plus 123. Okay, and similarly y also can be written as c into 10 to the power n by 2 plus d, where n will be 6 by 2 3, that means 352 into 10 to the power 3 plus 120. So this part is the first part of the second number, this part is the second part of the second number. Okay, now you have to keep dividing this thing and using recursive strategy. In this Karatsuba algorithm, it uses recursive technique to calculate the multiplication. So you can see here we have taken two numbers x and y. So x has been represented like this, just now we saw, and y also represented like this, c into 10 to the power n by 2 plus d, and x can be represented as a into 10 to the power n by 2 plus b. So we have divided it. So finally what we want x into y here, right? So x into y, if you write, that means you replace x with this and y with this, then you will get this into this. Okay, so this is d, this into this. Now here if you finally organize it properly, so you will be left with these terms only, a into c, because this a and this c will be multiplied, a into c into 10 to the power 2 into n by 2 plus ad plus bc into 10 to the power n by 2 plus bd. So that means this expression x into y, finally you will be having majorly three component. First is ac, second one is ad plus bc, third one is bd. So we have to calculate this ac, ad plus bc and bd recursively using Karatsuba divide and conquer strategy. This is the algorithm you can see. So these are the three component AC, AD plus BC and BD. So first AC, just simple multiplication, nothing is happening, just simple multiplication. For AC calculations, we have Karatsuba call, which is A, we are calling A into C, these two things. BD also we are calling B into D. And finally we have to calculate AD plus BC, which is again we can write Karatsuba A plus B into A plus B, comma C plus D minus AC minus BD. Okay, this is D minus BD, this is BD, okay, D minus BD. So why so? Because AB plus CD minus AC minus BD, finally you are getting AD plus BC. So I can write this thing here, same thing I can write it here, right? So just to give a call for the multiplication of A plus B, comma C plus B, Karatsuba multiplication means simple multiplication, recursive multiplication, same way, division method, and then AC minus BD you have to subtract. So these three components we can calculate like this, and we can finally find the results. So here you can see that one example you have taken two numbers, one is 1234, another one is 8765. So you can write it like you can write x equal to like this, 12 into 10 to the power 2. Why 2? Because 4 digit number 1 2 3 4, 4y2 equal to 2, 10 to the power 2 plus 34 the second part. Okay, and this y also you can write similar way like this, 87 into 10 square plus 65. Okay, that means 65 is the second part and 87 is the first part. So this is A, this is B, this is C, this is D. Okay, like that. So finally if you put this AC will be calculated, but how the recursive call will happen using state space tree, that you have to find. So you can see here divide and conquer strategy. So two numbers are there. So first number is 146 123, this is 1, first number is 146 123, and second number is 352 120. So both the numbers are 6 digit numbers, 3 3 6 6, both are 6. So you just simply divide it, first number will be divided, second number also will be divided. Just put this is A, this is B, and this is C, this is D. Okay, so as I said, what are the components you have to calculate? First you have to calculate AC, then you have to calculate BD, and then finally you have to calculate AD plus BC, okay, which is AD plus BC. This third one is this one. Every time you have to do that, AD plus BC. So for the similarly, so here it comes. So basically while calculating AC is A is 146 because this half part is coming, and 352 is coming from the first part of the second number. So this is AC. Again you have the opportunity to divide this number. You have to keep dividing the numbers unless it becomes single digit numbers. Even the two numbers also you have to keep dividing it. Now here you can see that 146 is there. The length of the number is 3. So 3 by 2 equal to 1.5. We'll take the ceiling value. So again 14 will come here, and then here it will be 35. Okay, so here again you have to divide this A, B, and then C, D, like that you have to do. So further one cannot do further partition. So this is 1, 3, which is 3. So AC, no, first it is C, this is C, AC, and then second one is BD, this is B, this is D, this is BD, and third one is AC plus AD plus BC. You have to calculate AD plus BC, AD plus BC. Okay, AD plus BC you have to calculate. So here AB 1 is coming here, 1 and 3 AC, which is nothing but 3. Then BD 4 is coming here, and then 5 is D, so which is 20. And then finally you have to calculate AD plus BC. For AD plus BC, what is the formula? Just now you have seen AD plus BC formula is very simple. We'll give a call for AD plus BC. You will give a call to Karatsuba A plus B, comma C plus D minus AC minus BD. So you have to remember this. So here you can see A plus B into C plus D minus AC minus BD. You have to give a call here, right? So here A plus B is 1 plus 4, C plus D is 3 plus 5, which is, that means 5 into 8, which is 40, and then minus AC minus BD. AC is 1 into 3, 3, and BD is, why it is so? Because just now you have seen here, right? A plus B, here A plus B, C plus D minus AC minus BD. So similarly you are doing it here, minus AC is 3, 1 into 3 3, and BD is 4 into 5 20. So it is 17. So 17 is there. Okay, so finally you have to just this expression is there. You put AC value as 3, you put AD plus BC as 17, you put BD value as 20. So altogether it is 490. So from here 490 will be returned to the next root node, immediate root node. Okay, father node you can say. So this is a subtree, this whole thing is a subtree. So here 490 will be returned, 490. Okay, similarly you have to calculate the other side of the tree. That means other two things you have to calculate BD. So you can see 490 has been returned here, 490. So here you can see BD is getting calculated. So this is AC part is done. Next BD part. BD part is very simple. This is B. This is D. 6 into 2 12. 12 will be called. Further no more further partitioning is possible or divided. You cannot divide further 6. You cannot divide further 2. These are all one-digit numbers. So you return it. So 12 will be returned. And then finally AD plus BC will calculate, that also will be having some value, we will return that value, so which is 740. So 740 also will be returned from here to the next immediate, the father node. Okay, so parent node. So this is 740 will come from this side, 740, and then this is 12, this is 490, like that things will happen. And then so you can see 490, 12, 740, these three things goes there. Now you have to calculate, similarly you have to calculate the other things also. Okay, this is just an AC part is happening. Now you have to calculate BD, and AD plus BC also you have to calculate for that, whichever. So this is the final results you can see. So this is 490, 12, 17, and then again it will get calculated here. All these things will be calculated. Okay, now everything will be returned to the final root node. This also will be returned final root node, and again you have to put this value as AC into this AB plus BD. Results you will get 51452830760, which is the final results you will get at the top root node. Okay, top root node you will get. So this is the space tree that you have to show, or recursive tree you can call it. You have to show in Karatsuba algorithm. Now this is the algorithm. Okay, sorry, a little bit not that much clear. Karatsuba XY. Here you are calculating A, B, C, D, because let's say we are dividing the number A, B, C, D. So A, B, C, D are calculating. So B and D is calculated in modulus arithmetic. Half is nothing but n by 2. That means whatever is the length of the number by 2 will be the half. So for the timing, let's assume that both the numbers length are equal. So let's say 6, first number is 6 length, the second number is length also 6. So 6 by 2, 3. That's been 10 to the power 3, 10 to the power 3, 10 to the power 3, like that. Okay. Now here you are giving AC call, Karatsuba AC. Second one is BD call, Karatsuba BD, and third one is AC plus AD plus BC, which is Karatsuba A plus B, comma C plus D, and then minus AC minus BD. So, and then finally we are returning this total tree. Okay, this value. So what is the time complexity? So first one is applying divide and conquer strategy. So it will be T n by 2. Second one also applying divide and conquer strategy. Length is n, means n by 2. Every time you are partitioning by 2 like that. Okay. These are also nothing. This is also partitioning only just A plus B comma C plus B. After it is also divide and conquer. So n by T n by 2 plus, and then this last return statement will give you theta n. Okay, so 1 n by 2, second n by 2, first n by 2, second n by 2, third n by 2. That means 3t n by 2 plus theta n. So if you see here, 3t n by 2 plus theta n, this is the time complexity, total time complexity, and let's see whether it is better than n square or not. So master theorem we will be applying here. You know master theorem. First condition of the master theorem applicable here. So which is n to the power log b to the power minus epsilon. Epsilon is a positive quantity. So finally we are getting theta n to the power 1.5. So this is greater. So basically theta n to the power 1.5. So that means n to the power 1.5 is slightly less than n square. Okay, so n square, you saw the naive method is giving n square, but it is giving 1.5, n to the power 1.5. Okay, so this is how Karatsuba divide and conquer strategy for multiplying two numbers is slightly better than naive way of multiplying two numbers.